Welcome to this explainer, where we're going to completely rewire how you picture the birth of, well, everything. We are throwing out that pop culture imagery of a giant explosion in space, and we're diving into the true physics of the everywhere stretch.
I mean, ask almost anyone, right? Was the Big Bang a giant explosion? They'll probably tell you it was this massive eruption of matter bursting outward from a single intensely hot point into an empty void. It's a super compelling image, for sure, but it is absolutely fundamentally wrong.
The absolute most crucial thing to wrap your head around is that the Big Bang was not an explosion throwing cosmic shrapnel into some pre-existing void. Instead, it was an expansion of space itself. It's what we call an everywhere stretch. Literally, space expanded everywhere, simultaneously. There's no center to this expansion, and there's definitely no edge. The distances between points in the universe just began to grow.
And this brings us to a really massive misconception: the initial singularity. You know, people so often picture this tiny, ultra-dense physical dot, or a little cosmic pebble that just suddenly popped. But in reality, a singularity is just a mathematical artifact. It literally just signifies the exact point where Einstein's equations of general relativity completely break down. The math just spits out infinite density and temperature, so it's really a glaring sign of missing physics, not an actual physical state of matter.
To really grasp this kind of metric expansion, we've got to use a classic mental model. Picture a slightly inflated balloon representing space, and imagine you've glued some pennies all over the surface. Now, as you blow up that balloon, the rubber stretches, pulling all those pennies apart from each other. From the perspective of any single penny, all the other pennies are moving away, right? And there's no center on that two-dimensional rubber surface. But here is the absolute key takeaway: the pennies themselves do not expand. In our universe, those pennies represent gravitationally bound systems, like massive galaxies or our own solar system. Local forces like gravity and electromagnetism hold them tightly together, even while the actual space between them heavily stretches out.
Okay, so with that mental model firmly in place, let's actually navigate the chronological journey of the early cosmos. We're going to take a trip from just a tiny fraction of a millisecond after the beginning, all the way to hundreds of thousands of years later.
We've got to start at the very edge of human understanding, time zero, or the Planck era. This is during the first 10 to the negative 43 seconds. Just impossibly brief. This is the era of quantum gravity, where all the fundamental forces were squished together and unified into a single force. The universe was basically this wild, roiling quantum foam. Actually, our whole concept of time might be completely meaningless here, which, by the way, is exactly why asking what happened before the Big Bang might literally be a nonsensical question.
Next up is cosmic inflation. Starting right around 10 to the negative 36 seconds, the universe underwent this incredibly rapid exponential expansion. Think about this for a second. Distances doubled every 10 to the negative 37 seconds. It's a completely mind-boggling scale of speed. Just like how inflating a super-wrinkled balloon smooths out its surface, this intense inflation ironed out and flattened the fabric of the universe. And crucially, it took tiny, microscopic quantum fluctuations and stretched them out to cosmic scales. Those stretched-out fluctuations literally planted the seeds for what would eventually become massive galaxy clusters.
Now, because inflation stretched everything out so violently fast, the universe was briefly this cold, empty place. But then the immense energy that was actually driving that inflation decayed, dumping all its energy into a hot thermal bath of particles. We call this explosive phase reheating. MIT physicist David Kaiser brilliantly describes this chaotic transition as the moment that transformed that cold void into the ultra-hot plasma we usually associate with the Big Bang. It literally puts the bang in the Big Bang.
If we trace this cosmic history forward, there's a really dramatic trend. Both the overall temperature and the density absolutely plummet. As space continued to aggressively expand, the universe naturally cooled down and thinned out. And this intense cooling is exactly what allowed entirely new physical processes to finally take over.
During these really early stages, the universe was essentially this incredibly hot, opaque soup. I mean, it was so hot that photons, particles of light, couldn't even travel freely. They were just constantly crashing into free electrons. Light and matter were totally locked in this continuous, chaotic dance of creation and destruction, with particles popping in and out of existence in a perfect, inescapable thermal equilibrium. But as the universe kept expanding, it finally cooled down just enough. Fast forward to about 380,000 years later.
the temperature dropped to roughly 3,000 Kelvin, which finally allowed those hyperactive electrons and nuclei to settle down and combine into the very first neutral hydrogen and helium atoms. We call this milestone the era of recombination. With those free electrons suddenly out of the way, they were no longer constantly scattering the photons. So almost in a flash, the universe abruptly snapped from being a light-trapping, opaque fog to fully transparent, open space.
This monumental event unleashed the universe's first free light, which we know today as the cosmic microwave background, or the CMB. And here's a crazy fun fact for you. This was discovered completely by accident back in the 1960s by two radio astronomers. They initially thought the persistent static they were picking up in their telescope was just caused by pigeon droppings on the antenna. But no, they were literally hearing the echo of the Big Bang itself. As space stretched out over the next 13.8 billion years, those original light waves stretched right along with it, cooling all the way down to a freezing 2.73 Kelvin. Today, we detect that stretched light as an ancient, faint microwave static humming all around us.
So, I want to leave you with a final thought to chew on from this explainer. The cosmic microwave background is quite literally a wall of light. It is the absolute furthest back in time we can ever physically see. So, if the Big Bang was a vast expansion of space itself, rather than an explosion in it, what profound truths might still be hiding deep in that unimaginable quantum foam before time as we know it even began?